Awesome.
You can see.
Okay, so before we ended the last session, we talked about packages and installing them. So I said, once you are in our environment, once you open up any session in our environment, the first thing you want to do is to install the packages, because the packages are what is like the apps on your phone. Those are what gives you the power to be able to work in R. So the first thing to do once you get into R is to install your packages. And I mentioned that one very important package is the Tidyverse package. Tidyverse is Tidyverse. So this is a very important package, being that it's a combination of other packages. It has the ggplot2 package in it. It has the janitor package in it. It has the forecast package in it. It has the deployer package. So with Tidyverse, you can do almost any analysis that you want. You don't even need to install any other package if you have the Tidyverse. But there are some functions that you might need to install other packages. For example, when you want to import a data set from somewhere into our studio, there's a function that you need that is not within the Tidyverse package. But basically your analysis, your data manipulations, your data visualizations, and analysis with Tidyverse, you can do almost anything. Please, can we mute our audios? I can hear some voices on the background. Okay, so to install a package in R, you use the function install the packages. Now, let me tell us something in R. Once you're typing anything in R, R begins to give you a list of, it begins to predict what it thinks you want to type. For example, as I started typing INST, R begins to bring out the things that it assumes I want to type. And if that thing is within this list, I can just select it instead of having to type everything. So since I have install packages here, I can just select it. Sorry, my system is finding so install. I select it. What's wrong with you? Let me do this again. Install. Okay. So install packages, and then it opens up a bracket, and then you put in your inverted commas and you write Tidyverse. Now, there are certain instances in R where we use inverted commas. I will tell us a few of them as we get to that point. But this is one of them. When you're installing a package using this install the packages function, whatever package it is always has to be in inverted commas or in quotes. So if I do this and I press Control Enter, you can see in the console, it installs the package for me, but you can see what is writing for me here. It's saying package Tidyverse is in use and will not be installed. Now that brings me to what I want to tell us in here. Once you install any package in R, you only have to do that once. Once you have installed it, you don't need to install it again. For example, that's why it's telling me will not be installed, because I have installed Tidyverse on my system already. However, when you want to use that function in any fresh session, you have to load that function so as to be able to use it. So there are two different things. There is installation and there is loading. Installation is done only once. Once you've installed, you don't have to install again. But loading is done with every new session you open up in R. You have to load the packages to be able to use the functions. Okay, so I have installed this, and then to load it, you type library and then Tidyverse. So if you notice here, I didn't put Tidyverse in inverted commas because it is not required here. Like I said, install the packages. When you're installing a package using install the packages, you need to put the package in inverted commas or in quotes. So to load the function, to load the package, I write library, and then in brackets, I put the name of the package in it, and we click Control Enter, and then it loads the package. I have it already loaded. If you look at my console, it's loaded here already. Okay, so that's how to install packages in R. If let's say you have 4 or 5 packages to install, for example, then you have to do install. Let's say I want to also install the real package. Install real. So I said it has to be in inverted commas. So real. Control Enter. You see, whatever you type in the source always translates to the console. So you can see here, it's telling me package real is in use and will not be, because I have installed it already in my system. Let's assume I want to install packages, Pacman. Don't forget your inverted commas. Control Enter. Okay, so now this package Pacman hasn't been installed, so it's actually installing. And then at the end, it will just tell me that package, can you see what it says here? Package Pman successfully unpacked and MD5 sum checked. So it has installed this package for me. Okay, so you can see, let's assume I'm working on, I want to use 10 different packages to work on R. So I have to do each of them individually, install the packages individually. And then also at the end, after that, I have to load each of them individually using the library function. However, some people have developed a better function for us to use to install packages, which is the Pacman package. So using the Pacman package, you don't have to, okay, let me just show us how to use it. Pacman, you put double colon, P underscore load. So here I would write tidyverse real Pacman. So if you look at this code I just wrote here, now Pacman is a package in R, and the main function is that it provides the pload function, which is used to install and load packages. Now, in these first examples I showed, to install, you use a different package. To load, to install, use a different function, and to load, use a different function. However, this Pacman package, it installs and loads the package at the same time. So you don't have to do installation differently and loading differently. And you can see I can do more than one package at the same time. So I can do tidyverse package, real package, and Pacman package all within the same line of code. Unlike in using install packages when we have to do them individually. And then if you also notice here, we don't need to use our inverted commas. You can just write this in yourself. Just separate the packages by a comma, and then you do that. So and the thing is that before you use the Pacman package, you have to install it first. So which we have done here. So this is the only time when you need to use install package, because you need to install Pacman. But after installing Pacman, then you can now use Pacman to install and load other packages in R, if you can see it here. So if I click Control Enter in this one, so you can see here, it has installed and loaded my tidyverse, my real, and my Pacman. The beauty about Pacman is even if you have installed that package before, it just goes ahead and loads the package for you. If you have installed it before, it goes ahead and loads the package for you. If you've not installed it before, it installs the package and then it also loads the package. So that's the beauty of using the Pacman package of installation of packages in R. Okay, having said that, we'll move quickly to importing data sets into R. Okay, to import data set into R, you use the import function and another function we call here, and then you write what's it called? The data set you want to import. For example, I told us I created a data set called voters, which is an Excel. So this is another place where you use your inverted commas, voters.xlsx. So this function here, I just wrote, I'm telling R to import something. Here means I'm telling R that data set is located in this directory. And then I write the name of the data set, which is voters. I write what type of file it is. Voters is an Excel file. So that's what this XLSX means. And then I put everything in quotes. And then I close my bracket. If I run this code, you can see in the console, it has imported that data for me. This is the code that we run. And this is the data set that it just imported, which has name, age, sex, weight, height, state. So it has just imported this data set into R, and then it immediately keeps that object in the environment. So you can see voters in this place. So this is summarily how to import a data set in R. Next, I want us to look at creating a project and opening and saving an R script. Okay, if you went through the documents I sent that were attached to your email, I detailed how to create a project in that document. And to create a project in R, you just need to come to this R place. You click File, and then you click New Project here. I don't know, someone sent me a message that when they clicked on File, that they did not see New Project. So I was surprised about that. You click on File, you come to New Project, and you click New Project. It opens up these documents. Because I have some things I'm already working on, I don't want to. Can you mute your audio? Someone is distracting us. So please just look at that document. How to create a project is clearly explained there with pictorial representations that show that. Sorry, please, can you mute your sound, please? Okay. So, please, can you mute your sound? Someone is distracting us on the background, please. Please, can you mute your sound? Mute your audio, please. Fortune. Fortune, your audio is on. Can you mute your sound? Okay, so the next thing is to open up and save an R script. R script is just like what it's inside this source where you write all your code. So creating a script, you come to File, you click on New File, and then, File, New File, and then R script. And then it just opens up the script for you, and then you can save it. Let's assume I want to save it as TOSARIF. Let's say TOSARIF. So you can see here, this new script I just opened, I've named it as TOSARIF. So that's just how to save a new script in R. So let's go back here. Okay, so we basically looked at what R basics are. So right now we're going to be moving into our data analysis or data management process itself. Okay, so once you are presented with data, there's what we call the 6 steps of data management process. The 6 steps of data management process. Most of us, I including, before I got this knowledge, once we are presented with data, we usually want to just rush in and begin to analyze and make tables and create visualizations and all that. But that is not the appropriate thing to do. You need to follow a systematic pattern in order to manage your data adequately. And so that whomever is reading your script can see the way you've gone from A to B to C to D, and they can appreciate it. And it's also something that is obtainable across the globe. So you need to follow this systematic pattern of data management process. So let's list them. The first is explore. You want to explore your data, exploration. The second is cleaning. You want to clean your data. The third is manipulation. The fourth is description and summarization. The fifth is visualization. And the last one is analysis. So these are the 6 basic steps of your data management process. Once you have a data set in front of you, the first thing you want to do is to explore the data. Then you clean the data. Then you manipulate the data. Then you describe and summarize the data. You visualize the data. And finally, you analyze. Once you follow these steps, you can never go wrong. And then anyone that is looking at your work can see how you moved from step A to B to C to D to E to F. It's very, very good to follow this systematic pattern. So we're going to take each of them individually. One is exploration. So what do we mean by exploration? Exploration just means try to understand the characteristics and the components of your data set. Have a summary of what this data is all about before you dive in to start doing other things with the data. Learn about that data. It's like having an affair with your data. Let me just use that word. Having an affair with that data. Try to know about that data. And once you have a data set, there are certain functions in R that we basically use to learn about data or to explore data. I'm going to list some of them. First, you have what we call the, sorry, I need to be, yes. Dim. Dim function tells you about the dimension of the data. You have the structure. This tells you about the structure of the data. You have the glimpse function. You have the, what we call names. Oh, sorry, let's say scheme. You have, so let me put a space here. You have heads. You have tail. You have names. You have class. You have unique. You have, what else we have? Okay, let's look at this basic ones first. So we're going to use this data set that I made. This data set, I said it's a data set that has 19 observations. I just wrote down the names of 19 people arbitrarily. They're not real people, just for the sake of our training. I wrote down the names of 19 people. I assigned different ages to them. I assigned different sex to them, weight, height, and what states they are from. So we'll use this data set to look at the exploration step in data management process. So let's go back to our scripts. Where is it? Practice. Okay, so dimension. Dimension tells us the number of rows and the number of columns that any data set has. So let's run dimensions. So you write DIM, and then you write the name of the data set, which is voters. Control Enter. So if you look at the console here, it tells us that dimension, voters, 19, and then 6. The first number is a number of rows, and the second number is a number of columns. Also, we can say 19 is a number of observations, and 6 is a number of variables. Variables are in columns, observations are in rows. So that is what DIM tells us. Then the next thing we talked about is structure. So we're going to run the structure function. So str, bracket open, and then we write our voters there, Control Enter. So structure gives us a summary of our data set. So this is the function we just ran, structure of voters. Now it tells us that this data frame has 19 observations, you can see it here, and has 6 variables, just like what we learned in the dimension. It gives us the names of the variables on this line. You can see them: name, age, sex, weight, height, and state. It tells us what class those variables are. You know, summarily in statistics, we have 2 categories of data, or 2 classes of data. We have the numerical data, and we have the categorical data. R calls categorical data as character. So you can see he's telling us here, name is a character variable, age is a numerical variable, sex is a character variable. So like that, like that. So this column just tells us what class the data set is, sorry, the variable is. And then after that, it now gives us the values, the first few values in each variable. For example, in the variable name, it tells us there are Aminu, Adebowale, Amara, Bola, etc., etc. In the variable age, it tells us there is 25, 19, 34. So structure gives us a summary of the data set. The next one is glimpse. Glimpse also gives us a summary of the data set, just like structures. So I've written glimpse and I've run the code. So the same thing that structure did for us, it tells us the rows are 19, the columns are 6. It gives us the names of the variables here. It tells us the class of the variables and a few values within that variable. The next one is scheme. Scheme also gives us a summary of the data set. However, it gives us a more detailed summary. Let's see what scheme does for us. So scheme takes each variable. Okay, first of all, this is our scheme voters. So it tells us the name of the data set is voters. It has 19 number of rows and 6 columns. And then it tells us of the variables, 3 of them are character variables, 3 of them are numeric variables. It goes ahead. It takes the variable type character, which is name, sex, and state. It tells us if there are missing values within that variable. Here, there is no missing value. It means all of them are complete. And then it tells us minimum, maximum. And then this is an interesting one, n_unique. Unique means the specific values that are within each variable. For example, within names, it's telling us there are 19 unique values. It means there are 19 unique names in the name variable. Now, for the variable sex, it says there are 2 unique values. And those 2 unique values are the male and female under sex. So that's why it's telling us that there are 2 unique variables in female. Under state, it tells us there are 15 unique variables. You know there are 19 observations, but under state, it says 15 unique variables. That means more than one person, more than one person is in one state. Maybe 2 or 3 people are in one particular state. That's why the number of unique variables here are 15. So this is a summary of the character variables. It also goes ahead and summarizes the numerical variables for us. For example, the age. It tells us that there are no missing data in age. It tells us the mean of the age is 40.8. The standard deviation is 18.5. The minimum value is 19. The 25th percentile is 29. The 50th percentile, which is the median, is 34. The 75th percentile is 44.5. And then the P100, which is the maximum value, is 90. So this gives us a summary of numerical variables, each of them, age, weight, and height. So that's what scheme, this function scheme, does for us. It picks each variable and summarizes it for us. Okay, so next we go to heads. Head just gives us a list of the first 6 rows in each data set. So, for example, this is head voters, and this is number 1, 2, 3, 4, 5, 6. So the first 6 observations in a data set, that's what head tells us. Its counterpart, tail, also gives us the last 6 observations. You can see these are the last 6 observations with tail. Then if we use names, names tells us the names of the variables that are within that data set. So you can see names, voters, it tells us there is name, age, sex, weight, height, and state. So these are the names of the variables that are within that data set. What else did we say? We talked about class. So class tells us the class of a particular variable. So we can say class, we want to know the class of age. And it tells us that age is a numerical variable. You can see that in the console here. Age is a numerical variable. So basically, once you use these functions, it begins to just give you a summary of what your data set is like. You know how many rows you have, how many columns you have, you know what class of variables there are, you know the summaries of your numerical variables, the mean, the median, the maximum, minimum, and all that stuff, the standard deviation. You know the first 6 lines of a variable, you know the last 6 lines of a variable. So those are things you can do. And then you can also find what else do we miss? Sorry. Name, structured names, scheme, head, tail, names, class. Okay, unique. There's the last one we missed. So unique tells you the unique values within a variable. So let's, for example, look for the unique thing in sex, for example. Sex is here. and then we click Control Enter. So you can see it tells us that the unique values in the sex variable are M, which is male, and F, which is female. If we look at the data sets, voters, let's look at it here. Where are you, voters? So you can see under sex, we have M and F, M and F. So these are the two unique values within this variable. Okay, let's go back to our scripts. Practice file, where are you? Good. So these are functions you can use summary to like have a summary of what your data set is all about. I would add one more session to today so that we can do data cleaning. So I want us to, this session is going to log out in the next 2 minutes, and then I will send a fresh Zoom link to your emails so that you can log into the next session. So once you do that, then we'll start data cleaning. But for now, I want us to ask questions or clarifications based on what we've done so far with data exploration. So the next 2 minutes, let's have some questions. No one has any question?
The question I have is the head function. What is it for? The head and tail function, what is it for? I didn't quite get that.
It just gives you the first 6 observations of that data set. Let's look at the data set voters. So if you press head voters, it just gives you this first 6 that I selected here. So you just want to know what your data set, the first 6 rows are. It might help you begin to understand the pattern of your data set. While tail gives you the last 6, which is this. The last 6 rows of your data set. So that's what head and tail do. Thank you for that question. Some other person will have less than 1 minute.
Maybe a quick question.
Okay, go ahead.
So when you're combining, did you use the $sign or which sign did you use?
Yes, the $sign is just to tell R what variable within that subset. What variable within that data set. You know our data set here is voters. So when we say voters and we put the $sign, we type any of these variables, it's just telling R work on, for example, we used sex here. We use sex here.